Hello everyone. In the last videos we have learned some problems on Laplace transformation. Today I am going to explain inverse Laplace transformation. So we know the definition of Laplace transformation. It is Laplace of f of t equals integral from 0 to infinity e power minus st into f of t into dt, which is nothing but f bar s. So Laplace of f of t equals f bar s. Then Laplace inverse of f bar s is f of t. So this is the inverse transformation formula. So for example, we know the Laplace of 1. It is 1 by s. Then what is Laplace inverse of 1 by s? It is 1. We know the Laplace of cos phi t. It is s divided by s square plus 25. Then Laplace inverse of s divided by s square plus 25 is cos phi t. Similarly, for Laplace of 1 over s square plus a square. Here I require a to get sin a t. So multiply and divide by a, will get 1 by a into Laplace inverse of 1 over s square plus a square is sin a t. So similarly, Laplace of 1 over s cube is t square by 2 factorial, because Laplace inverse of 1 over s power n plus 1 is t power n plus 1, t power n divided by n factorial. Okay. Now I am going to solve some problems on Laplace inverse transformations. Here we have s plus 2 divided by s square plus 36 plus 4s minus 1 divided by s square plus 25. So we need to find Laplace inverse for this. I can write this as Laplace inverse of s divided by s square plus 36 plus Laplace inverse of 2 divided by s square plus 36 plus, for this it is 4 into Laplace inverse of s divided by s square plus 25 minus Laplace inverse of 1 over s square plus 20. We'll get, so we know the Laplace of cos 60 formula. It is s divided by s square plus 36. Then what is L inverse of s divided by s square plus 36? It is cos 60 plus. Similarly, to get sin 60, here we require 6. So we don't have 6, so we have 2 here. So multiply and divide by 3, we'll get 1 by 3 into 3 into 2 is 6. It is sin 60 plus 4 into cos phi t minus, again I require phi here, so 1 by 5 into sin phi t. So this is the required Laplace inverse. Okay. Similarly, for this problem we have Laplace inverse of 2s divided by 4s square plus 25 minus Laplace inverse of 5 divided by 4s square plus 25 plus Laplace inverse of 8 divided by 16s square plus 9 minus 6 into Laplace inverse of s divided by 16s square plus 9. So L inverse of 2s divided by, here we require the coefficient of s square as 1. So take 4 common, we will get s square plus 25 by 4. S square plus 25 by 4. So minus L inverse of, similarly for this we will get, take 4 outside, it is s square plus 25 by 4 plus L inverse of 8 divided by, similarly this one take 16 common, it is s square plus 9 by 16 minus 6 L inverse of s divided by, take 16 outside, it is s square plus 9 by 16. So it is nothing but 2 1s are 2 2s are 1 by 2 into L inverse of s divided by s square plus 5 by 2 whole square minus L inverse of 1 by 4 into 5 divided by s square plus 5 by 2 whole square plus, so 8 1s are 8 2s are, it is 1 by 2 into L inverse of 1 over s square plus 3 by 4 whole square minus 6 by 16 L inverse of s divided by s square plus 3 by 4 whole square. So to get the result, 1 by 2 into, here I can write s divided by s square plus 5 by 2 whole square as cos 5 by 2t minus 1 by 4 into, here we have 5 by 2. So here we have only 5. So I require divided by 2 here. I require divided by 2 here. So multiply 2. Multiply and divide by 2. We'll get 2 1s are 2 2s are. So minus 1 by 2 into, now I can write this as sin 5 by 2t plus, similarly we have s square plus 3 by 4 whole square. So here I require 3 by 4. Multiply and divide by 3 by 4. 3 by 4 and 4 by 3. So 2 1s are 2 2s are. It is 2 by 3 into sin 3 by 4 t minus 3 by 8 cos 3 by 4 t. So this is the required result. Okay, we have one more. Find the L inverse of s plus 2 whole cube divided by s power 6. So simplify this. What is a plus b whole cube? What is a plus b whole cube? It is a cube plus b cube plus 3a square b plus 3ab square. So I can write this as L inverse of a cube plus b cube is 8 plus 3a square b. 3 into a square is s square, b is 2. So 6s square plus 3ab square. It is 3 into a is yes, so b square is 4. 4 into 3, 12s divided by s power 6. So I can write this as s cube by s power 6. It is nothing but 1 over s cube plus L inverse of 8 divided by s power 6 plus 6 into L inverse of s square by s power 6. It is 1 over s power 4 plus 12 into L inverse of 1 over s power 5. So which is nothing but, what is the Laplace inverse for this? Laplace inverse of 1 over s power n plus 1 is t power n by n factorial. So it is 1 over s cube, means it is nothing but t square by 2 factorial plus 8 into 1 over s power 6. It is t power 5 by 5 factorial plus 6 into t cube by 3 factorial plus 12 into t power 4 by 4 factorial. So we can simplify this. We will get t square by 2 plus 5 factorial, 5 into 4 into 3 into 2 into 1. It is nothing but t power 5 by 15 plus 3 factorial, 3 into 2 6, 6 6 cancel, t cube plus t power 4, 4 factorial is 24. So divided by 2. This is the required result. Next, inverse transform of e power minus as into f bar s, means we already know by using unit step function we have proved this. F of t minus a into u into t minus a is e power minus as into f bar s. Here f bar s is L of f of t. So I can write now L inverse of e power minus as into f bar s as f of t minus a into u into t minus a. For example, look here, we have 2 by s square, 2a by s cube e power minus 3s and 3 into e power minus 2s by s. What is the Laplace inverse for this? 3 into Laplace inverse of this is 1 over s square plus 2 into Laplace inverse of this e power minus s into s cube minus 3 into L inverse of e power minus 2s divided by s. So what is L inverse of 1 over s square? It is t. What is L inverse of 1 over s cube? It is nothing but t square by 2. What is L inverse of 1 by s? It is 1. See here, it is in the form of e power minus as into f bar s. E power minus as into f bar s. Then what is the inverse for this? If we have e power minus as into f bar s, then the result will be, then the inverse of Laplace transformation will be f of t minus a into t minus into u into t minus a. By using that, I can write this as 1 over s square is 3 into t plus, because we don't have any e power minus s minus 2s like that. Here we have that 2 into L inverse of what is 1 over s cube? It is t square by 2. By applying e power minus s, look here, then this becomes f of t minus a. F of t minus a means t minus what is a? It is 1. T minus 1 whole square into u into t minus 1 plus what is L inverse of 1 by s? Minus 3 into 1 into, if we have e power minus 2s, then this comes in the form of e power minus as into f bar s. Then result will be f of t minus a. So we don't have t here, so write 1 into u into t minus a. It is t minus a. What in the place of a we have 2, it is u into t minus 2. So this is the required result. I'll explain with one more example now. Look here, I have one more example. Now we need to find the Laplace for this. L inverse of e power minus pi s divided by s square plus 1 plus L inverse of s into e power minus 2 pi s divided by s square plus 4. We know the value of e power L inverse of 1 over s square plus 1. It is sin t. Similarly, we have L inverse of s divided by s square plus 4. It is cos 2t. Now the result is, we have sin t into e power minus as into f bar s. So f of t minus a, this is f of t. So f of t minus a is t minus a, in the place of a we have pi. So sin into t minus pi into u into t minus pi plus s divided by s square plus 1 cos 2 into t minus 2 pi u into t minus 2 pi. So sin of t minus pi, so take minus outside, it is minus sin of pi minus theta is sin t. It is minus sin t into u into t minus pi plus cos 2t minus cos 4 pi. So if I take minus outside, cos of minus theta is cos theta, then we will remain with cos of 2 pi minus t. It is cos 2t u into t minus 2 pi. I think now you have understood well for these type of problems. That is f of t minus a into u into t minus a equals e power minus as into f bar s. I will take one more example now. So multiply this 1 into 2, it is 2, 1 into this e power minus 2s minus 2 into e power minus s minus into minus plus e power minus 3s divided by s cube. So find the L inverse of 2 by s cube minus L inverse of e power minus 2s by s cube minus L inverse of 2 into e power minus s by s cube plus L inverse of e power minus 3s by s cube. So what is L inverse of 1 over s cube? It is nothing but t square by 2 factorial. T square by 2 factorial means t square by 2. Now Laplace of this 2 divided by s cube is 1 over s cube is t square by 2. It is just t square minus t square by 2 L inverse of 1 over s cube into e power minus as. Now I have to write this t into in the form of f of t minus a. What is a here? 2. So this becomes t minus 2 whole square into u into t minus 2. Similarly this one, minus 2 into t minus 1 whole square, t minus 1 whole square into u into t minus 1 plus 1 over s cube. Finally this one is t minus 1 whole cube, t minus 3 whole square by 2 into u into t minus 3. So if you have the question in the form of e power minus as into f bar s, then the result will be f of t minus a into u into t minus a. So next we have one more method to solve inverse Laplace transformation methods, inverse transformation problems, that is inverse transform by completing the square method. So completing the square method means shift, we have to write now shifting property of Laplace transformation. What is a shifting property? If L of f of t equals f bar s, then Laplace of e power at into f of t is f bar of s minus a, f bar of f minus a. By using this, if L inverse of f bar s is f of t, then L inverse of f bar s minus a equals e power at into f of t. Similarly, if you have f bar of s plus a, then this will be e power minus at into f of t. Now I am going to solve some problems based on these things. Okay. So first one problem, s plus 5 divided by s square minus 6s plus 13. We have s square minus 6s plus 13 in the denominator. This in s square minus 6s plus 13. Now we need to make this s square minus 6s plus 3 in the form of s minus a whole square, something like that. So that is I can write this as s square minus 2ab means minus 2ab 6s. We need to make this in the form of a minus b whole square, that is s minus something whole square. S square minus 2ab, what is b now? It is 3. B square means 9. So plus 9 minus 9 plus 13. Plus 9 minus 9 will get cancelled, then will remain with the same thing. So nothing will change by adding and subtracting 9 and minus 9. By using this, I can write s minus 3 whole square plus 13 minus 4. 13 minus 9 is 4. Now I can write this as, so L inverse of this, s plus 5 divided by s minus 3 whole square plus 4. If we have s minus 3 whole square in the denominator, then we need to change all s in the question in the form of s minus 3 only. Then only we can easily take s minus 3 outside by using this formula. Okay, so L inverse of, in the place of s we need s minus 3, so minus 3 plus 3, add and subtract minus 3 and plus 3. So if I take plus 3, then plus 3 plus 5 is 8 divided by s minus 3 whole square plus 4. So take s minus 3 outside now. By using this L inverse of s minus a, I can write that as e power at, it is a power 3t. Then will remain with L inverse of s plus 8 divided by s square plus 4. Now we can easily simplify this. L inverse of s divided by s square plus 4 plus, so we have e power 3t here, plus L inverse of 8 divided by s square plus 4. So this is nothing but e power 3t into L inverse of s divided by s square plus 4 is cos 2t plus L inverse of s square plus 2 square. S square plus 2 square, here we require 2. So multiply and divide by 2, will get 4 into sin 2t. So here we have s square minus 6s plus 13. So make this s square minus 6s plus 13 in the form of a minus b whole square. So to apply this, completing the square method formula, so that's why I have taken s square minus 6s plus 13 as s minus 3 whole square plus 4 by adding and subtracting 9. After that we have s minus 3 whole square plus 4 in the denominator. If we have s minus 3 in the denominator, then change all the s in the question. Wherever you get s, then you need to change s to s minus 3. So after changing s minus 3, I can write this s minus 3. It is in the form of f bar of s minus a. Apply L inverse for this, we will get e power 3t. Then we can easily simplify this. Okay, now I will explain with one more problem. Now we have s square and s plus 1 whole cube in the, we have s square in the numerator and s plus 1 whole cube in the denominator in this problem. See here, we have s plus 1. Then make all s in the question in the form of s plus 1 only. So we have s square. So make this s square as s plus 1 whole square. It is s plus s. Make this s square in terms of s plus 1 whole square. If you have s plus 1 whole square, what is s plus 1 whole square? S square plus 1 plus 2s. So we have 1 and 2s extra. So make it as minus 2s minus 1. So then s square equal s square is nothing but now s plus 1 whole square minus 2s minus 1. But here we have s. Again we need to change this s in the form of s plus 1. Make this s as s plus 1. It is s plus 1 whole square minus 2 into s plus 1. So minus 2s minus 2. Minus 2s minus 2. Now minus 2s extra. So again plus 2 means it is 1. So now I can write s square as s plus 1 whole square minus 2 into s plus 1 plus 1. So this problem becomes now L inverse of s plus 1 whole square minus 2 into s plus 1 plus 1 overall divided by s plus 1 whole cube. Now apply L inverse for s plus 1. Then I can write this, if you have f bar of s plus a, then e power minus at into f of t. So we will get e power minus t. Then this becomes L inverse of s square minus 2s plus 1 divided by s cube. Now we can simply solve this. It is nothing but e power minus t into L inverse of s square divided by s cube. It is 1 by s minus 2 into L inverse of s divided by s cube. It is 1 over s square plus L inverse of 1 over s cube. So finally the result is e power minus 2 into L inverse of 1 by s is 1 minus 2 into L inverse of 1 over s square is 2t plus s cube is t square by 2. Okay, now I will take one more problem. Find the Laplace inverse of L inverse of 2s minus 1 divided by s square plus 4s plus 29. As it is, take the denominator s square plus 4s plus 29. Make it as s plus 2 whole square. S square plus 2ab. It's already we have, so 4s. It is nothing but 4s. S square plus 2ab plus b square is 4. So subtract minus 4 plus 29. If I cancel plus 4 and minus 4, will remain with s square plus 4s plus 29. So I can write this as s plus 2 whole square. 29 minus 4 is 25. So now this becomes L inverse of 2s minus 1 divided by s plus 2 whole square plus 25. So here we have s plus 2. So make this s as s plus 2. Then this becomes L inverse of 2 into, simply write s plus 2, multiply this 2s plus 4, so 4 is extra, plus 4 is extra, so minus 4, already we have minus 1, it is minus 5 divided by s plus 2 whole square plus 25. So here apply L inverse for this, we will get e power minus 2t into L inverse of, to this becomes s minus 5 divided by s square plus 5 square. So it is nothing but e power minus 2t into L inverse of 2s divided by s square plus 5 square minus L inverse of 5 divided by s square plus 5 square. So final answer is e power minus 2t into 2s divided by s square plus 5 square is 2 into cos 5t minus sin phi t. So this is the result. Now I will take one more problem. See, L inverse of 2s plus 1 s square plus 3s plus 1. So take this s square plus 3s plus 1 now. a square plus 2ab. We have 3. So divided by 2. 2 by 2 cancel. So we'll get 3. So what is b now? It is 3 by 2 plus b square means 9 by 4. Subtract that minus 9 by 4 plus 1. It is nothing but s plus 3 by 2 whole square minus 5 by 4 LCM. So I can write this as L inverse of 2s plus 1 divided by s plus 3 by 2 whole square minus 5 by 4. So it is nothing but L inverse of, make this s as s plus 3 by 2 now, s plus 3 by 2 plus 2s plus, multiply this 2 inside. So 2 get cancelled, plus 3 is extra. So plus 3 minus 3 means plus 3 minus 3 plus 1 is minus 2. Overall divided by s plus 3 by 2 whole square minus 5 by 4. So apply L inverse for this. So we will get e power minus 3 by 2t into 2s minus 2 divided by s square minus, it is nothing but root 5 by 2 whole square. Root 5 by 2 whole square. Now, so e power minus 3 by 2 t into L inverse of 2s divided by s square minus root 5 by 2 whole square minus L inverse of 2 divided by s square minus root 5 by 2 whole square. So e power minus 3 by 2t into L inverse of 2 into s divided by s square minus root 5 by 2 whole square is nothing but cos hyperbolic root 5 by 2 t minus, to get sin hyperbolic, here we have root 5 by 2. So multiply root 5 by 2 and divide by root 5 by 2. We will get minus 2 into 2, 4 by root 5 into sin hyperbolic root 5 by 2 t. Now I will take one more problem. S divided by s square plus 4 into a power 4. Take this s power 4 plus 4 into a power 4. I can write this as s square plus 2a square whole square minus 4a square s square. See here, yes, it is in the form of a plus b whole square minus 4a square s square. Expand this s square plus 2a square whole square and cancel, will get s power 4 plus 4a power 4 only. Now I can write this as it is in the form of a square minus b square. What is a plus b into a minus b? S square plus 2a square minus plus 2as into s square plus 2a square minus 2as. A square minus b square is a plus b into a minus b. So make this s in the form of this. So I can write 4as as s square plus 2a square plus 2as minus s square plus 2a square minus 2a square. S square 2a square minus s square plus 2a square will get cancelled, will get the same thing. So now I can write this as L inverse for this. So L inverse of, in the place of s I can write 1 by 4a into, in the place of s I can write s square plus 2a square plus 2as minus s square plus 2a square minus 2as. Overall divided by s square, s power 4 plus 4a power 4 is s square plus 2a square whole square minus 4a square s square. It is nothing but a square minus b square. I can write this as s square plus 2a square plus 2as s square plus 2a square minus 2as. So it is nothing but 1 by 4a into L inverse of this, and this will get cancelled. I can write this as s square plus 2a square minus 2as minus this s square plus 2a square minus 2as, and this one will get cancelled. S square plus 2a square plus 2as. So I can write this as 1 by 4a into L inverse of 1 over a square plus b square. It is in the form of s minus a whole square plus a square. Expand this, we'll get the same thing. Minus 1 over s square s plus a whole square plus a square. So I can apply L inverse of 1 over s minus a, will get e power at into L inverse of 1 over s square plus a square minus 1 over s square plus a square. So e power at and e power at by 4a, and for this it is e power minus at divided by 4a, and L inverse of 1 over a square plus a square. So I can write this as e power at, 1 over 4a is constant, e power at into this one 1 by a into sin at minus e power minus at, again 1 by a into sin at. So 1 by 4a into, take a outside, it is a square, take sin at as also outside, will get e power at minus e power minus at. What is e power at minus e power minus at? It is 2 sin hyperbolic at. So that 2, and we'll get this to cancel. So 2a square into sin at into sin hyperbolic at. So this is the required result for this problem. Next one, we have one more method in inverse Laplace transformation. So now I am going to find inverse transform by the method of partial fractions. I'll explain this with an example now. Okay, take this example, 1 over s plus 1, s plus 2, s plus 3. So write this in the form of, write this s plus 1, s plus 2 into s plus 3 by, I can write this by using partial fractions. It is a by s, b by s plus 1, c divided by s plus 2 plus d divided by s plus 3. So 1 equals a into, take LCM, and this function, that one cancel. So a into s plus 1, s plus 2, s plus 3 plus b into s plus 2, s plus 3 plus c into s plus 1, s plus 3 plus d into s plus 1, s plus 2. So put, to get the result, put s equals minus 1, s equals 0, s equals minus 2, and s equals minus 3. So 1 equals, put s equals minus 1 now. Minus 1 plus 1 get cancelled. Minus, for c is also 0, d is also 0. We remain with b only. So b into minus 1. Minus 1 plus 2. It is plus 1. Again minus 1 plus 3, it is 2. So b equals minus 1 by 2. Put s equals 0. 1 equals, we'll get b, c, d 0. So a into 0 plus 1, it is 1. 0 plus 2, it is 2. 0 plus 3, it is 3. A equals 1 by 6. Put s equals minus 2. 1 equals a, b, d will get 0. So c into minus 2 plus 1, minus 1, minus 2 plus 3, it is plus 1. So c equals plus 1 by 2. And if I put s equals minus 3, we'll get d value. So d into, it is minus 3 plus 1. Minus 2, and minus 3 plus 2, it is minus 1. So d equals minus 1 by 6. Substitute those results here and directly write, I will take L inverse, it is 1 by 6 into 1 by s for a. For b it is minus 1 by 2 into L inverse of 1 over s plus 1. For c it is plus 1 by 2 into L inverse of 1 over s plus 2, plus for d it is minus 1 by 6 into L inverse of 1 over s plus 3. So it is nothing but 1 by 6 into L inverse of 1 by S is 1 minus 1 by 2 into e power minus t plus 1 by 2 into e power minus 2t minus 1 by 6 into e power minus 3t by using L inverse for 1 over s plus 1, 1 over s plus 2, 1 over s plus 3 respectively. Okay. Okay, now I will take one more problem. L inverse of 4s plus 5 divided by s plus 1 whole square into s plus 2. So what is 4s plus 5 divided by s plus 1 whole square into s plus 2? By using partial fractions, I can write this as a divided by s plus 1, b divided by s plus 1 whole square plus c divided by s plus 2. By simplification, we will get 4s plus 5 equals a into s plus 1 into s plus 2. So b into s plus 2 plus c into s plus 1 whole square. So put s equals minus 1 and s equals minus 2 and compare the coefficient of highest term, that is s square, to get the results of ABC. If I put s equals minus 1, then 4 minus 1, so 4 into minus 1, it is minus 4 plus 5, 1 equals, so a into, this will get 0, b into minus 1 plus 2, minus 1 plus 2 is plus 1, so b equals 1. Put s equals minus 2, minus 8 plus 5, minus 3 equals minus 0, 0, c value, c is minus 2 plus 1, it is 1 only, c equals minus 3. If I compare the coefficient of highest term, s square, we don't have s square in the left side, so 0, here we have s square, it is a, plus we don't have s square here, we have s square here, it is a plus c. Since c equals minus 3, a equals minus c, it is plus 3, the value of a is plus 3. So by applying L inverse for this, directly I can write L inverse of, now I will apply L inverse for this. So a, it is 3 divided by s plus 1 plus b value, it is L inverse of 1 over s plus 1 whole square plus c value, it is minus 3 into L inverse of 1 over s plus 2. Now I can write this as 3 into e power minus t plus 1 over s plus 1 whole square. 1 over s plus 1 whole square, it is nothing but e power minus t into 1, we will get 1 over s square, it is t, 1 over s square minus 3 into e power minus 2t for 1 over s plus 2. Okay, I will take one more problem, that is L inverse of 5s plus 3 divided by s minus 1 into s square plus 2s plus 5. So 5s plus 3 divided by s minus 1 into s square plus 2s plus 5 equals, I can write this as a by using partial fractions, a into s minus 1 plus, we don't have complete whole square here, so bs square plus bs plus 5s, nothing but bs plus c divided by s square plus 2s plus 5. So simplification, 5s plus 3 equals a into s square plus 2s plus 5 plus bs plus c into s minus 1. So to get ABC, put s equals plus 1, put s equals 0 and compare the highest coefficient, it is s square. If I put s equals 1, so 5 plus 3, it is 8 equals a into, so 1 minus 1, 0, 1 plus 2s, 1 plus 2 plus 5, it is 8, so a equals 1. So put s equals 0, we will get 3 equals, if I put 0, we will get 0 plus 0 plus 5, 5a, bs 0, 0 plus c, again 0 minus 1, it is minus c. So we will get 3 equals, 5 into a is 1, so 5 minus c. So minus c, take this to here, so 5 and take 3 to here, we will get 5 minus 3 as 2. Next compare the coefficient of s square, we don't have s square in the left side, so here we have s, a plus, again bs into s, bs square, so we will get only b. So b, since a is 1, b equals minus 1. So substitute those values here, substitute those values, and directly I will take L inverse for this. So we will get a, it is L inverse of 1 over s minus 1 plus b, it is minus s plus c divided by 2 into s square plus 2s plus 5, s square plus 2s plus 5, L inverse of this. I will take this now. First I will take this, I will take, mark it as star. Consider this. For L inverse of 2 minus s divided by s square plus 2s plus 5, make this by, solve this by using completing the square method. It is s square plus 2ab plus 1 minus 1 plus 5. I can write this as s plus 1 whole square plus 4. So it is L inverse of 2 minus s divided by s plus 1 whole square plus 2 square. So make this also s plus 1 minus s plus 1 minus s minus 1 is extra, plus 1 means it is 3. So the inverse for this is e power minus t into L inverse of 3 minus s divided by s square plus 4. So final inverse for this is e power minus 2 into L inverse of 3 divided by s square plus 4 minus L inverse of s divided by s square plus 4. So the result is e power minus t into 3 divided by s square plus 4. I require 2 in the numerator. So multiply and divide by 2. Multiply and divide by 2. We will get 3 by 2 into sin 2t minus it is cos 2t. So star becomes, this star becomes L inverse of 1 over s minus 1. It is e power t, and for this we have this answer, e power minus t into 3 by 2 into sin 2t minus cos 2t. Next, if we have log in the question, then to get inverse we require second property of Laplace transformation, that is derivative property. What is that derivative property? If L of f of t equals f bar s, then Laplace of t into f of t is nothing but minus f bar dash of s. So now I will write, if L inverse of because L inverse of f bar s is f of t, I can write minus f bar dash of s as t into f of t. Now I will use this to get the result. I will explain this with an example now. First one, log of s plus a by s plus b. This is nothing but f bar s. This is our f bar s. So to get the inverse, it is in the form of log of m by n. What is log of m by n? It is log m minus log n. Log of s plus a minus log of s plus b. We have f bar s now. I require f bar dash. So differentiate with respect to s now. We will get f bar dash of s equals 1 over s plus a, differentiation of log minus 1 over s plus b. Again I require minus also to get L inverse of minus, to get t into f of t. Multiply by negative sign, we will get minus f bar dash of s equals 1 over s plus b. This comes first, minus 1 over s plus a. Now apply L inverse for this. We will get 1 over s plus b minus L inverse of 1 over s plus a. It is nothing but e power minus bt minus at. So the result is, what is L inverse of minus f bar dash of this? T into f of t. So f of t equals divided e power minus bt minus e power minus at divided by t. So this is the result for this log of s plus a by s plus b. Remember this question. We have already solved this question in the property number 3, that is integration transform property. Remember that. So in that problem we got this result. So now we are doing the problem in the reverse way. We are getting inverse for this. Next problem, cot inverse of s by a. I will take this as f bar of s. It is cot inverse of s by a. Then differentiate this. differentiate with respect to s to get f bar dash of s. What is cot inverse x? It is minus 1 over 1 plus x square, that is minus 1 over 1 plus x square, it is s by a whole square into differentiation of s by a is 1 by a. This is nothing but, if I take LCM, we will get minus a square plus s square divided by a square into 1 by a. This a and this a will get cancelled, so this goes to numerator. It is minus a divided by a square plus s square. So this is our f bar dash of s, but I require minus f bar dash of s. So multiply minus, we'll get this as plus. Then L inverse of minus f bar dash of s is L inverse of a divided by a square plus s square. It is t into f of t equals sin at. So f of t is sin at divided by t. This is the result for cot inverse of s by a. Okay, now I will take one more. Log of square root of this. Square root of this means it is nothing but power 1 by 2 log of m power n. Then what is f bar s? It is 1 by 2 into log m by n. So log of m by n is log of m log m minus log n. Log m power n, it is n log m, but in n log m we have log of m by n, so it is log m minus log n. As it is, differentiate this with respect to s. 1 by 2 into, if I differentiate this, we will get 1 over s square plus 1 into 2s minus again 1 over s square plus 4 into 2s, differentiation of this. So take this to outside and 2 will get cancelled. So f bar dash of s equals, and multiply minus because I require minus f bar dash of s. So this 2 will get cancelled, will remain with s divided by s square plus 4 minus s divided by s square plus 1. Apply L inverse for this. Apply L inverse for this. We will get t into f of t equals cos 2t minus cos t. So f of t, the result is cos 2t minus cos t divided by t. Now I have taken one more problem. See, here we have s log s plus 4 by s minus 4. Then what is f bar s now? It is s into log m by n, log of m minus log n, log of s minus 4. So differentiate this with respect to s. Differentiate with respect to s. We will get f bar dash of s equals s into log of this UV method, product rule, this function into the differentiation of this function. It is 1 over s plus 4 minus 1 over s minus 4. I will write this s to inside plus again second function into differentiation of first function, log of s plus 4 minus log of s minus 4. So differentiation of s, what is differentiation of s? It is 1. So we will remain with this. Now usually after this step we multiplied with negative sign, then we took L inverse in the previous problem. But here we can't take L inverse because still in the problem we have log. So again differentiate this. So differentiate twice. Differentiate with respect to s again. We will get f bar double dash of s equals differentiation of s divided by s plus 4 u by v method, denominator square into differentiation of numerator minus numerator into differentiation of denominator is 1. S will get cancelled. It is 4 divided by s plus 4 whole square minus, similarly this will get s minus 4 whole square into minus 4, that is plus 4, plus differentiation of this 1 over s plus 4 minus 1 over s minus 4. So this is nothing but s4. Now I can take L inverse of f bar double dash of s now. Here we don't need to multiply negative sign because for L inverse of minus f bar dash of s is t into f of t. For f bar double dash of s, it is t square into f of t. So no need to multiply negative sign. So we'll get L inverse of 4 divided by s plus 4 whole square plus 4 into L inverse of 1 over s minus 4 whole square plus L inverse of 1 over s plus 4 minus L inverse of 1 over s minus 4. So the final result is t square into f of t equals 4 into e power minus 4t into, will remain with 1 over s square, it is t plus 4 into e power plus 4t into t plus L inverse of this e power minus 4t minus e power plus 4t. So divide this t square now. F of t equals 4 into e power minus 4t divided by t. 1 t get cancelled. 4 into e power t divided by t plus e power minus 4t minus e power plus 4t divided by t square. This is the required result. Here we differentiate this problem twice. Okay. So these are the assignment problems. Try to solve this. We can solve this by using logarithmic method. We can solve this by using partial fraction method, and now we can solve this by using completing the square method. And here we have e power minus s. E power minus s. Remember the unit step function formula. It is f of t minus a into u into t minus a. So after getting the result by using completing the square method, we need to apply e power minus s to get the result. Okay. So today we have solved some problems on inverse Laplace transformation. So we have used completing the square method, e power minus as into f bar s method, and partial fractions method, and also logarithmic method to get the results. In the next video, I am going to explain inverse transformation by the method of convolution.